So this is the chapter review for chapter 8 on page 521. Starting on number 1. We're multiplying all these terms across here. We're going to multiply the coefficients like normal. So 2 times 3 is 6, times 4 is 24. And we're multiplying a similar base, so we're adding the exponents. And so that's going to give you a total of, oh, looks like I copied it down wrong. This should be a 3. So 2 and 3 is 5 plus 4, 9 total. So adding exponents, multiplying coefficients. Number 2, this is now a quotient, meaning division. So you're subtracting these 4. If you wrote out 4 of them and 8 on top, these 4 would cancel 4. So you'd still have 4 of them left on top. And the 6 over 12, that gives you 0.5 or 1/2, which we're going to write as a fraction. But basically what we're doing is taking the 6 over 12 and reducing it down, which becomes 1/2. We don't write the 1 in front. It's okay if you do, but you're not going to see that on an answer key. And then the 2 goes on the bottom. So final answer, y to the 4th over 2. Number 3, another quotient, just with more than one variable. And some negatives. So first of all, your 7 and your 3 are going to stay. You can't simplify that any farther. X's are going to cancel, so those go completely. Oh, never mind. I did miss that 2 right there. So we got 1x on top and 2 on the bottom. Since there's no negatives, we can just go ahead and cancel. So there's 1 on top, there's 2 on the bottom. So one of them cancels, but that means there's still 1 left on the bottom. When you have a negative, you need to move it and make it positive, and then combine it with whatever else is up there. So I'm going to have 4y's or y to the 4th up top. So we got b to the negative 2 times 4b to the 5th. So this is really a 1, and you're timesing it by 4, so that's 4. And then you're going to go ahead and add your exponents here because we're multiplying, and so we just get b to the 3rd, and we're done. So don't try and fix that negative to start with. You can put it to the bottom and then cancel it with the 5, but in my opinion, that's more work than it needs to be done. Just go ahead and combine it. If you have a negative, fix it later. All right, I'm going to throw number 5 over here. So we have v to the 4th power over v to the 8th. Whole thing's raised to the 6th. So you got options. You can cancel first if you want, or you can raise everything to the 6th power and then cancel later. When you raise to the 6th power, you're just multiplying. So that would be 6 times 4, and we would get 24 up top. And then you also have to do 8 times 6. So you're going to get 48. And so then these cancel. And so these 24 cancel 24 of these, meaning there are still 24 left on the bottom. And since the top is completely canceled, you're going to put a 1 there. So the other way you could have done it is you could have canceled these. And so you would have had nothing left on top and 4 left on the bottom. Raise that to the 6th power. Now 1 raised to the 6th is 1 times 1 times 1 times 1. So it's still 1. And then this raised to the 6th will get you v to the 24. So either way, whichever way makes more sense, perfectly fine to do it both ways. Jumping to number 8. So we're going to rewrite this expression without the negative exponents. That's really what we're getting at here. So we're actually going to skip. The part without fractions means you're going to move everything from the bottom to the top and just make it a regular number that might have negatives, but that's really kind of useless for us. So I'm really only worried about part B here. Write it without the negatives. So the a has to come to the bottom. Nothing there to combine it with, so it's a to the positive 1, which we don't have to write. The c is going to stay right where it's at. The b, this b needs to go up and become a positive, so it's going to combine, and you'll have b to the 6th up top. And that's really all we're concerned with. If you're confused on part A, don't worry about it. They just took these and moved them up. So this would become positive, of course, but the c would become negative, and that's what you would see on part A there. And so 9, similarly, you're going to take this and move it up. So now you have 4x's on top, x to the 4th. 60 over 45. You can find something that fits into it, like 5, or 15 would be the best one. So if you divide them both by 15, you're going to get 4 on top and 3 on the bottom. And remember, you can always use your fraction function. So alpha x, put in the 60, put in the 45, and it'll reduce it for you 4/3. All right, so here's your final answer. We're going all the way to 14 straight through here. So right to number 10, we're going to rewrite negative a b to the negative 1 without a negative exponent. So negative a can stay up top. Negative 1 goes to the bottom. So it ends up looking just like that. All right, so we're going to go ahead and multiply here. But let's combine this first before we start worrying about moving negatives all over the place. So 7 times 6 is 42. And you still have x to the negative 7, y to the negative 3rd. They stay separate. Okay, you can't start combining those exponents because they're not the same base. Both of those, though, now need to come to the bottom. So 42 is going to stay right up top. Bring the x down, make it positive. Bring the y down, make it positive. And we're good to go. Okay, what does this look like with regular numbers now? So 4 to the negative 3rd. You try and put that in your calculator, it gives you a decimal. We're going to rewrite this as a fraction, though, without a negative exponent. So we just take the whole thing and throw it to the bottom. It becomes positive. You've got to fill that top space with a 1. And then you actually expand the bottom. So 4 to the 3rd is 4 times 4 times 4, which is 64. So 1 over 64 is the same as 4 to the negative 3. So 13, 6 to the negative 2, throw it to the bottom. So 1 over 6 to the positive 2, which is 1 over 36. 14, 1 over 10, raised to the negative 2. Okay, so both of these need to get the negative 2. So 1 to the negative 2, 10 to the negative 2. And so we want to make them both positive before we do anything else. So move it up to the top. So we get 10 to the positive 2 up top, 1 to the positive 2 on the bottom. Now 1 to anything is 1 times 1 times 1. So that's just going to be 1. It's going to be something over 1. And 10 squared is 100. So it's 100 over 1. We don't need the 1 on the bottom. It's just 100. All right, from 14, we are going to 27. So we're just going to simplify this expression. So that negative 4 has got to come to everything. So the negative 8 is going to be raised to a negative 4, and the s is going to be raised to a negative 4. And the t squared you're going to multiply here. You actually did here too, but it's a 1. So 1 times negative 4 is negative 4. And the 8 actually has a 1. The negative 8 has a 1, so you multiply. And then t squared, you're going to multiply, so it's t to the negative 8. So basically, everything here is just going to move. So it becomes t to the positive 8 up top. It becomes s to the positive 4 on the bottom. And it becomes negative 8 to the positive 4 here. So that one we actually are going to have to expand here. So negative 8 raised to the positive 4 is 4,096. So our final answer here, t to the 8 over 4,096 s to the 4th. Okay, 28. All right, so we're multiplying these two things together, but exponents do come first. So we need to take care of this first before we handle this. So when I bring this in, I'm going to multiply. It becomes m to the 6th and n to the negative 9th. Now I can bring this down and multiply. So we're still just adding exponents now, not multiplying. We multiply when it's a power to a power. Here we're multiplying, so we're adding exponents. So we're going to get m to the 9th, and we're going to get n to the negative 11, which now needs to shift down. So we get m to the 9th on top and n to the positive 11 on the bottom. Let's start on a new page for 29. Keep that there so we know which problems to do. So 29 looks a little complicated, right? Y squared, z to the negative 3rd. On the bottom, 6y to the negative 3rd, z to the 4th. Whole thing raised to the negative 2. Now, you can go in and put a negative 2 on everything. You can. But we have things that are similar already. Z's on the top and the bottom, y's on the top and the bottom, and we have 2, 6, which can be simplified. And so you're allowed to fully simplify the inside before you raise it to the negative 2nd, and that will reduce the number of things that you need to bring the negative 2 into. So that's what I would do. So first of all, this is going to become a 1 over 3. I'm not even going to need to put the 1 there. This comes up, becomes y to the positive 3, combines, that's y to the 5th. Z to the negative 3 goes down, becomes positive, combines, that's z to the 7th. Now that's raised to the negative 2. So this will be a lot easier now to work with. So we're multiplying on the exponents, so that's negative 10. We're multiplying on the exponents, that's negative 14. And with the number, I'm going to go ahead and just place it on it and then move it. All right, so this whole bottom ends up coming back to the top because of the negatives. This top goes to the bottom, so everything flip-flops. So it's 3 to the positive 2, z to the positive 14th, and y to the positive 10. Okay, so the only thing left to do is 3 squared, which is 9, z to the 14th, y to the 10th. Jumping to 55. Yes. Okay, so going all the way back to 8-1, when we had determined how many different possibilities or combinations there are. So, the test contains 5 questions. 1, 2, 3, 4, 5. Remember, we used to put the blanks. And then you're going to put the number of options in each. It's either always, sometimes but always, or never. So 3 choices in each one. 3, 3, 3, 3, 3, which would be the same as 3 to the 5th. And 3 to the 5th is 243. And that's going to answer letter A for us. So how many different answer sheets are possible? 243. If you guess, what's the probability that you get all 5 correct? So there's only one way to pick all of those correct. And so the probability is 1 out of 243. Letter C is a little tricky. Now, I actually had to think twice about it when I was looking at the answers. So if you guess, what's the probability that you will answer all 5 incorrectly? Now, that doesn't mean that you don't get it perfect. That means every single one is wrong. So even if you were guessing, you're more than likely going to hit some that are right just by guessing. So let's redo this here. You have 5 questions. You have to get the first one wrong. Well, there's 3 options. So that means you have 2 ways of getting it wrong. You can't pick the correct one. And that's going to be the same for all of them. All right, each question, if we have to get every single one wrong, we have 2 chances to get it wrong on each one. But what's the chances that we get every single one wrong? So how many possibilities are there for that? So that is 2 raised to the 5th power, which is 32. So there's 32 chances. And so that is going to be out of the total number of possibilities, which is 243. Nothing that difficult on the test. It's just taking it a step further. Only part A would be on the test. How many different possibilities are there? Okay, 57. We got pizza, thin crust, and deep dish. Okay, there's 3 different sizes, and there's 9 toppings. How many different pizzas with 1 topping are possible? Okay, so we got to be careful here with how this is worded. because the first time you read it, you might think that we're eliminating the 9 toppings down to 1. But that's not actually what we're doing here. So they're just saying there's only one topping possible. So you're not going to combine, say, pepperoni and sausage or something like that. If you can only get one topping, you got to pick a crust, you got to pick a size, and one topping. How many different pizzas are there? Because if you start mixing the toppings together, that creates a whole new number of possibilities. So that's why they had to put that in there. So you have to pick a crust, and there's 2 choices. You have to pick a size, and there's 3 choices, and you have to pick a topping, and there's 9. And so you're just multiplying straight across, and that comes out to 54 options. All right, 65. So 65 tends to be one that some students do more work than they actually have to on it, because they use the distance formula for everything. Now it'll work. So for AC, if you use these points and you run through the distance formula, it'll get you the right distance. But because this is laying flat on these lines, we can just measure it like a ruler, and we can find out what it is. So for AC, it's 1, 2, 3, 4, 5. So AC equals 5. Part B, BC, right here, it's laying flat on those lines. You can use it like a ruler, and that is 3. So BC equals 3. Now, part C, what about AB? This one you can't count across boxes because it's diagonal. Okay, so the diagonal lines on a graph, you have to either use the distance formula, or in this case, we can use Pythagorean theorem since this is a right triangle. So both of these will get you the right answer, whether you go a squared plus b squared equals c squared, and you're going to plug in 5 squared plus 3 squared equals c squared, because across from your 90, that's your c. That's what we're looking for. So that's 25 plus 9 equals c squared. So that's 34. All right, and it doesn't tell you how to round or anything like that. So you would take the square root here to get it just c by itself. 34 doesn't have any perfect squares in it, so you would leave it square root of 34. You could get the decimal and round it as well. Now let's say you chose to use the distance formula. So we're finding the distance between -2, 1, and 3, -2, because that's from A to B. So distance formula. Subtract your x's and square it, plus subtract your y's and square it, and at the end you square root it. So go in this direction. X is -2 minus 3. That's going to be -5 squared, which is a positive 25. And your y's, it's 1 minus -2 squared goes plus plus. That's 3 squared, and that's 9. And look at that. We get 34. This was all under the square roots. And so we end up c equals square root of 34 both ways. So either way is fine, whichever way you want to solve it. All right, and 67 and 68, we're going to go ahead and just run that distance formula. So we've got 211 and 11.2. Similar numbers, right, to make it a little complicated. So here we go. I'm going this way. I'm doing 2 minus 11, x and x. And I'm doing 11 minus 2. So I'm going to get -9, and I'm going to get +9. Now both of them, when you square them, is 81. And so that's 162. Got a square root. Square root of 162 is not a nice number, so if we're going to simplify that into simplest radical form, you want to try numbers like 4, like 9. Now 9 works. Now if 9 works, you want to try 81 as well, though, because 9 goes into 81, and that'll get you there faster. So 162 divided by 81 is 2. So I can split this into 81 and 2, and the reason I would choose that is because 81 becomes 9. Now let's say you didn't see that. So let's try it. Let's say you did 9. So 162 divided by 9, and you got 18. So you would have had 9 times 18, and you would have said, oh, 9 becomes 3, and I'm done. But you got to check this one right here. If this can be split again, you have to, and it can, to 9 and 2. The 3 follows along. This 9 then becomes a 3. So you still have that 3, and that becomes 9 radical 2. So either way, you're going to get to the same answer. But if you choose 9, you should check 81 on a big number like that because it will speed up your process. All right, last question to do, number 68. So we're finding the distance from 6, 5 to 3, negative 5. So subtract your x's, 6 minus 3. Subtract your y's, 5 minus negative 5. So that's 3 squared or 9. And this is 10 squared or 100. Together, that's a 109. And so we want to simplify that. And so 109 doesn't look like 4 is going to go in. What about 9? No good. You could try 16, but if 4 didn't work, 16 is not going to work. What about one of those goofy ones, like 7 squared is 49? Nope. 109. What about 64? Nope, that obviously doesn't work. And so there actually is not a perfect square that goes into it. And so this is fully simplified, and you can leave that answer just like that.